So we started off with -2 equals 7 or 6/7 p. In order to get rid of the 6/7, we have to multiply by the reciprocal, so 7/6. And if we do that to this side, we have to do it to this side, right? So when I do that, these two things cancel each other. We're left with p. When I multiply this straight across, I just do -2 times 7, -14, and we keep the bottom the same, because this is technically -2 over 1, and 1 times 6 is just 6. So we get this, and then I realize, oh, this can be simplified even further, so I divide both numbers by 2, giving me -7/3 equals p. And this is the multiplication property of equality, because I multiplied to solve the problem. Now over here we have kind of the opposite case. We use the division. So here I see I have 3 pi d equals 12 pi. Something I notice is that when we're dividing, if we have a bunch of things being multiplied, let's say we had like 10 things next to each other and they were all being multiplied, you could literally divide by 9 things all at once, which means you can divide by any number of things all at the same time. So I don't have to do this one step at a time. I don't have to divide by 3 and then divide by pi. No, I can actually divide by 3 and pi at the same time, because the 3's will cancel each other out here. Which, let me show that. 3's canceling out right here. And then the pi's cancel each other out, which leaves me with just d, right? And then over here I get 12 divided by 3, which is 4. But then I also get the pi's canceling out. Kind of just a nice thing that just happened to work out, right? So the answer is d equals 4. And that's the division property of equality, because we use division to solve the problem. Okay, let's shift gears and go to the next section. Or not the next section, but I should say the next part of this. This is the last thing we have to look at. So if you need to, go ahead and pause here and copy down these notes if you would like to, or you can pause at the end, but I'm just going to walk through what we're doing here, okay? So these are called challenge problems. These are problems that have a lot going on, basically. They're not as simple as just one-step solutions. We have to solve some things first. So we're going to check for opportunities to simplify first. So every time we see an equation, let's take a, for example. Here's where I show it one step at a time, okay? So let's take a, for example. Let's say you had -3 equals h plus 8 divided by 2. What we'd want to do is we'd want to solve for anything that can be solved for. Notice that you can actually solve using PEMDAS. If you're using logic of PEMDAS here, you can actually solve 8 divided by 2 right now. You don't have to multiply by 2 and then subtract 8. In fact, it gets kind of messy if you try and do it that way. What you want to do here actually is you want to just simplify the problem, make the problem easier by dividing these two numbers. And so when I divide these two numbers, I get 4. And now the problem is just as easy as what we were doing before. Now I can subtract 4 from both sides, and I get -7 equals h, which is the subtraction property of equality. So you notice that even though I was dividing here, that's not the property I was using. The property I was using was I was balancing the equation by subtracting from both sides. Right? So that's the property I use. Then let's look at b. So b, if you don't remember how absolute value works, absolute value is basically, it asks the question, how far away is this number? So how far away is -7 from 0? Well, if I'm looking at a number line and I count, -7 is only 7 steps away. It's not -7 steps away, it's 7 steps away. I only count 7 times, right? So that means if I'm asking what the distance is away from 0, that means I'm always going to get a positive number. So another way you can think of this, if you don't remember the definition of absolute value, is you can just use the rule of thumb that absolute value always becomes positive. Doesn't matter if it's a positive number or a negative number in here, the answer will always be positive. Just get rid of the negative if you see it. If there's a positive number in here, just leave it alone. Just get rid of the absolute value, right? So we solve for that first. When we solve for that first, we get 7. But notice that the minus sign is on the outside of the absolute value. So we have to consider the minus sign still, right? We did make this positive, but now we're subtracting a positive number, okay? So now from here, I'm going to do what I did before, and I'm just going to add to both sides, and I get 19 equals W. And I use the addition property of equality here. Okay? So now that we've done that, let's go ahead and do numbers 35 through 38. And I'll see if we can, if you want to pause the video and try them yourself right now, you can, but I'm just going to go through them on here as quickly as I can to show you how to do them. So let's start with 35. 35 says Q plus absolute value of 6.4. And I'm going to make these lines nice and big so I know it's absolute value and not a 1, right? Equals 9.6. Okay, so remember, we're not just going to subtract here. We need to solve this first. So if we're solving this first, we're asking the question, how far away is this number from 0? Well, we can also go off of the rule of thumb we said, which is just take the positive number. This is already a positive number, so guess what? I just leave it alone, and I get rid of the absolute value sign. That's what's nice here. It doesn't change to a negative. A lot of people think it changes signs. No, it just always becomes positive, okay? Subtract 6.4 from both sides, and I get Q equals 3.2, okay? And then the property we used here was the subtraction property of equality, okay? And then now let's do number 36. I'm trying to see if I have enough room over here. I think I do. Let's do 36. D minus 2.8 divided by 0.2 equals negative 14. Okay, so here I'm just identifying what I need to solve first. I'm going to go ahead and circle the two numbers that can be simplified first, so I can actually solve what this is. Negative 2.8 divided by 0.2. Remember that when we're dividing two things, or if we change it to a fraction, you can actually move the decimal first, okay? So I'm going to think of this as negative 28 divided by positive 2, okay? If I move the decimal place once here, I can also do it here. In fact, let me go ahead and write that in. Okay, so now I have negative 28 divided by 2. Negative 28 divided by 2 is negative 14. Which that kind of looks familiar, right? So we're going to add 14 to both sides to get d by itself. And we find that d is equal to, well, these two actually cancel each other. But I have to write something here, so when these two cancel each other, I'm left with 0. Okay? Don't forget, 0 is a real number. We're not going to forget about 0. Addition property of equality. Okay? Let's go ahead and do number 37. So number 37 is 8/9 is equal to x plus 1/3 times 7. Okay? So just like before, I'm going to circle the thing that I can simplify first. So I'm simplifying this first before I solve. So this is 8/9 is equal to x. And now let's solve what this is. So 1/3 times 7, well, this is the same thing as 1/3 times 7 over 1. So when you're multiplying, you just multiply straight across. We get 7 over 3. Okay? And just like I said before, when I'm adding and subtracting fractions, I need to make sure I have common denominators. So what I can change here is this is a 9, and I can change 3 into a 9. So let's go ahead and do that. Multiply top and bottom by 3, which will change this to 8/9 is equal to x plus 21 over 9. Okay? Now I'm going to subtract 21 over 9 from both sides. We're subtracting a bigger number from a smaller number, so this is going to make a negative answer, but they're going to fight each other, so they're going to basically take away from each other, so we can subtract these two numbers basically. So 21 minus 8 is 13, but the negative number wins the battle because it's bigger, so negative 13 over 9. These two get canceled, and I'm left with x. And so here, ask the question, what did I use? Well, I subtracted from both sides, right? So this is SP, subtraction property. Okay, and then final part is 38. 38 is P minus 14 times 3 equals negative 5, 6. Remember that the first step is to solve first, or to not solve, simplify first. So I'm going to simplify this to 3/4 or negative 3/4. Once again here, I need to have common denominators. The smallest number that these two numbers can both go into is actually 12. So to get 12, I need to multiply by 3 here. To get 12 here, I need to multiply by 2. Okay? Remember, you got to multiply the top as well. So P minus 9 over 12 is equal to negative 10 over 12. Okay? Add 9/12 to both sides, and I get P is equal to negative 1/12, and that's the answer. We used the addition property of equality because we added to both sides. Doesn't matter what I did here. It's all about what did I do to both sides to balance the equation.